Okay, I'm back over here to the table, and what I've done is put another coat of primer on, and there's some areas where there was little imperfections, something like that, little like pinholes, stuff like that. Hey guys, welcome to another update on the carbon fiber intake build for the 8.3 Cummins. I just wanted to interrupt that clip that I was showing you there to just touch on a couple of things real briefly. I'm spending a lot of time telling you about making this thing as smooth as possible. You have to understand one thing, is it's a destructible mold. This thing is a destructible mold. So it's got to be right, and it's got to be right the first time, because there is no second chance for this thing. After I get this thing finished and lay up the carbon fiber, there's no turning back. The only way to get the mold out is to destroy it. So I want to be meticulous on this thing and get this thing as smooth and linear of a flow as possible into this. Now, I understand that once it goes into that head inlet, then things change, because it's not going to be smooth and linear inside of the intake on the head. There's a lot of rough openings, but my point is to get it to that point as smoothly and as efficiently and as possible. And then what happens inside the head is another thing. Now again, this is a racing engine that I'm building this thing for. It's a truck, a haul truck, and so I'm not looking for perfection. I'm looking for perfection up to the point of getting it into the head. If I was looking for perfection in the head, I would take that intake off and put runners onto it, form this thing differently, so that there was runners directly into each intake port of each cylinder on the head, and you didn't have that tunneled intake plenum on the head. But again, I'm spending a lot of time on it to make sure that it is as perfect and smooth as possible, because again, I'm not worried about the outer appearance of it as much as I am more concerned about the smooth inner flow when I take this mold out. But I'll bring you back. I've got spot putty, or glazing spot putty, and what that is, it's an older product, automotive product, and what it is like a thick primer, and it's used to cover over small imperfections. You can't use it for big things, but small imperfections, just like scratches or something like that, you can use it for. But I've done that, and I'll keep doing that, keep sanding it down, keep priming it until I get it to where I want it. Things like that. If you can see that, I'm not really sure if it'll show up in the light. There's like a little dimple right there, and I will use it on something like that. Bring you back. Okay, so this is a clip that right after I shot that about the spot putty, and I kind of knew that this could happen, but I wasn't sure that it was going to happen. That spot putty reacts terribly with the foam. What it does is it softens it right up and dents it. So you're good to put that spot putty over an area that has been covered up with paint or filler, but you can't put it where it comes in contact directly with the foam, or it melts it. And that's what happened. Where was it? It was, okay, I'm going to interrupt you one more time here and just explain something. You're going to see me do some things here with body filler that should not be done in normal practice. You're going to see me use body filler over parts of this thing that have been painted. You should never do that in like body work type of situation, because there's a very good chance if you put body filler over a painted area, the vibration and time will peel that thing off of there. Body filler should only be used on like bare metal. You should never put it over paint. The only reason I'm doing it here is because, again, this thing is a destructible mold, and it's going to be, there's no long-lasting effect for this thing. It's only used as a temporary filler to make this thing smooth so that I can lay the carbon fiber over it, and then the mold gets destroyed again. Now, the same is not true with glazing or spot putty. That can be used on paint in a typical automotive application, because, again, what it is basically a primer, and that primer will interact with the paint that's on there and stick to it. So, body filler, never use over paint. Spot putty, glazing can be used over paint. It could have been here, but anyways, it came in contact with the foam, melted it, so what I had to do is mix up a small batch of body filler, and as long as I had it, there's a couple of other places that I hit too with it. But that spot putty is great stuff, except you can't let it come into contact with the foam. Yeah. So I'll continue on. I've got to sand that body filler off. Gonna reprime it and see what I've got. By priming it, it brings out that gloss and it shows up defects that you don't normally see in the product. And I'll kind of show it to you when I do it. After I spray it, I'll show you where the defects are that you didn't really see here. So the last video that I shot, I think that I told you that I'd bring you back and show it to you after I sprayed it, the imperfections in it. Well, I forgot to do it or didn't do it. And I filled in most of them, but there is still some. You can see there's kind of one up there, right there. But they're small. Just small little imperfections. Now, the underside, I've still got to work to do on it. But why the jigsaw and the drill were over here, I'll take you over and show it to you. So what I did is cut out a template to use when I go to after the carbon fiber is laid up and it's cured and everything's good. I've cut out a template that I can use that will that I can cut the flange out on the bottom of it. Now, I don't like the way it came out. A couple of the holes tore out when I drilled them. So what I've got to do is get a backer and maybe actually put it in the drill press and drill it with a backer. I'm probably going to cut a new one so that the whole pattern lines up perfectly. Again, yeah, that's probably what I'm going to do. I'm going to probably put the intake manifold right on top of the piece of laminate that I cut. It's not laminate, it's that 1/4 inch board that they use for flooring, subflooring, to straighten out uneven floors. I'll put the intake manifold directly on top of it and drill right through the existing holes. Now, there's a couple of holes that I can't do that to. The part where, let me shut you off and pull you back, but one other thing that I wanted to note is, I never noticed this when I took it apart, but for some reason there is two holes that are not used in the intake manifold. The holes were laid out directly off of that intake manifold. So as you can see, there was two other holes. So was there another intake manifold made that they utilize them two holes on? I'm not really sure, but I don't know why they're there, and they look exactly like factory holes. I mean, there's, yeah, they don't look like they were drilled in later. So I'm kind of wondering, was there another manifold that was built for this thing that maybe utilized them two holes also? I'll take you over and show you where I can't drill it through the drill press and why. But I can drill most of them. I think there's going to be two of them that I can't drill. Okay, so here we are over with the intake manifold, and that's the way it would sit. So there's two holes that I wouldn't be able to drill on the drill press. This hole and this hole that's kind of buried underneath the intake port of this intake manifold. But all of the rest of them I can just put on a drill press and drill them out with the drill press. These two I'll just have to end up marking and drilling them out afterwards. I'm over here to the bench where I'm doing the intakes for the A3 Cummins. This is a mold for the carbon fiber intakes. I should say carbon fiber Kevlar intakes now, because I'm going to also use Kevlar in it. What I've done is, the last video, the clip that I shot, I told you that I was ready to sand it down. Well, I found a couple of more spots in it. So what I did is just filled them. There were spots in the foam, so the under foam. So you can't use that spot putty on them because that spot putty reacts terribly with the foam. But what I did is just mixed up a little body filler, put it in there, sanded it off, spray painted over it, and that will take care of those areas, hopefully. I will find out once the paint dries and I can take a good look at it. I don't want to really touch it too much right now. I mean, it was right in here in the same way over here, but the paint is still a little tacky, so I don't want to screw with it. One of the things I've got to do is go out and get some modeling clay to form the bond between this and the underlayment that I'm going to put down, that I'm going to mount this onto, so that when I lay up the carbon fiber and Kevlar cloths, it's down there. It's going to also form the flange too. But so model clay, I'll show you how that gets used when I get it and get it back here. Okay, when I left you off the last time, I told you that I had to get some clay. The clay isn't going to actually form the bond between this. What it's going to do is fill in where this thing is put onto the board that is going to support it. That clay will just be used along the bottom edge to form a dam from any of the resin penetrating back underneath of it. So there's a couple of things that I've changed my mind about. I was using this like underlayment stuff. What I'm thinking about doing now is using a piece of 1x. I'm going to cut this 1x out and use that, because when I put that, use it, it will be better for a guide. In other words, the thicker material will be a better guide for the drill bit when I attach it, not attach it, but affix it to the bottom of the carbon fiber intake. It will provide more of a guide for the drill bit to go straight when I drill into the carbon fiber to form the holes for the in the flange. So I'm thinking about that. This is the material that will be used to create the dam, the outer dam around this thing, so that I can form the flange. And then what that'll be done is cut off to size afterwards. So the dam area will be bigger than the actual size of the intake, and it will be cut down afterwards to size. So just a couple, I'm going to end you here, and I just wanted to tell you about the changes that I've had to a couple of different things. I might not use this. I might go out and get a piece of like 1x8, that plastic, I don't know if it's like a PVC type of plastic trim they use. Instead of wood trim now, they have a white plastic trim that's like in a 1x, is the same as wood. I might use that just so it gives it better support on the bottom, and it's easier to work in case I have to flip it when I'm laying up the material. But anyways, that's going to do it for this one, part 11 of this. I'll bring you back, and hopefully next time when you come back, I will have some of these things done and starting to form up the jig for the molding it.